Professor Poeppelmeier, it's an honor and pleasure to be with you. This is Artist of Science, our signature series about scientists, about the world of scientists and engineers. Just to start, how happened when you went to science and engineering when you were a teenager after you finished the secondary school?
I mean, what first brought my interest to science, right?
What happened? What were the factors that...
Yeah. There were a couple of them. I mean, having important teachers in grade school, high school already,
Okay.
right? But perhaps more important, going to college, going to a university and having excellent teachers. And my first year in college, the freshman year, I did pretty well in chemistry, so the professor approached me, and it was a large university, the University of Missouri at Columbia, the main state school in the United States, but in Missouri. And he asked me to be his grader, and for the next 3 years, I would grade all of his exams.
Really? That's interesting.
Two of us, and we had about 300 exams to grade, and by hand, on paper, nothing was digital. So I literally did this for 3 years.
Around what year we are speaking?
This is 1967 to 1971.
Okay.
So the war in Vietnam was still going on, just ending, all this turmoil. And but I really learned to like chemistry, interacting with him. And
this was in high school or university?
No, college, university.
Oh, okay.
University, yeah.
Okay, but so you went to the university in chemistry. The major was chemistry.
Major was chemistry because of my high school teacher.
Oh, okay. Okay.
Then really learned to like chemistry by actually working with this professor for 3 years on all of his exams and talking about chemistry and this question, that question, that sort of thing. And then I went to the Peace Corps.
Yeah. Nobody told you it's better to go in law, in social sciences, in economics?
For me, it was just that experience just exposed me to so much chemistry. Okay. It just became the subject, and I've always loved chemistry because of that. But it really started there.
Correct. So no, pressure or no suggestion for family members, for friends, is better in law, it's easier profession, you make money more easier, easier, you don't...
So that, this is the late 1960s and in the 70s, and so those sorts of pressures and discussions were not very common.
Correct, yes.
This comes later, right?
Later, yeah. Correct.
And in fact, I think the sciences and engineering, if anything, there was that was a goal of a lot of people. Right? Mm-hmm.
So there was no question on deciding the field.
For me, there was no question.
Straightforward to chemistry. Yes, because of your high school teacher.
Yeah. Well, actually, I can even say his name. His name is R. Kent Merman. And he was just very influential, and even later, because his thesis advisor, he told me about him. His name was Professor Basolo, Fred Basolo, and so when I came back from the Peace Corps, then I knew what I wanted to do, and so I went back then to Iowa State University and worked with John Corbett in the area of inorganic chemistry. And Fred Basolo was a very famous name in inorganic chemistry. And so from that point then, I went to work at Exxon for 6 years after I finished my PhD. And, but I really respected Fred Basolo and Northwestern University. So at that point, I decided to leave Exxon, which was a very good place and a very good place. And that's where I met Stan Whittingham. But I went back to Northwestern University because that's where Fred Basolo was. So even from the very beginning, when I was working with Kent Merman, he had been Fred Basolo's first graduate, well, one of his early, I think actually his first graduate student. So these sorts of connections are really important, and that's why I was so happy with this symposium this week, because of all the connections to your students, right?
Perfect,
so
yeah.
That's really a part of sustainability.
Correct. Cannot agree more. It fits with our
It's all about
sustainability
people.
framework.
At some point, it's all about the people.
Yes.
So your colleagues.
So if you go back 30, 40 years in time and you have to choose the field, would you have decided differently in a different field from chemistry?
I don't think so. I just really like chemistry.
Correct.
But I think many chemists are that way, or people who are in maybe the sciences. And it kind of carries over into your own family, because my wife and I, we have 3 sons, and none of them have become chemists, but nonetheless, they know a lot about chemistry, even in what they're doing. And so it crosses over into what they're doing. And they often send me a message, well, hey, Dad, can you explain this? And I'm interested in it because some company is interested in it, or
in something related to chemistry.
Related to some question about law or business or whatever. So.
That was my next question, but you got it already there before me. What about the family? So they are not chemists, children are not chemists, but what's their profession?
At one level, they're all entrepreneurs. So very, very modern, I guess.
In what field? Because it depends which one.
In related fields, all with using technology, of course, right? So the oldest son is involved in the field of law and how court cases get carried out and how you have to collect all the sorts of information going into a court case. And the middle son is involved in, has been in a lot of startup companies, and right now he's involved with a company that wants to digitize the interior using augmented reality or whatever you want to call that, virtual reality. Their stated goal is the interior of all the buildings in the world. Well, that's a little exaggerated, and it's not going to happen. But they're making a lot of successes, with companies who need all that information. And the youngest son is involved with making video games in some sense, but he's been involved in a lot of things. The technology of how video games need to get across the platform that Microsoft has or Apple has or Google has. And so that's really important. So he's involved in that.
What about your wife? Scientist?
Not a scientist, but close. Her degree is in textiles and clothing.
Okay.
And in fact, she was really impressed with these bolas because she knows all about them.
Oh,
and so this is one of the things we were looking for in the shops, and we looked and looked to find some very delicate, some that were very, very well done. And so this is the sort of thing she's an expert in. But she's retired now, and I'm not quite retired, but so we're looking forward to, the next stage and enjoying our grandchildren and that sort of thing.
So it's better for a scientist to have the companion, the wife or husband, in the same scientific field, for example. It will be better we have a wife in chemistry in the same field. I'm speaking in general, not you personally.
Yep.
Or it's better to have in a different field to be complementary.
Well, I'm very biased. I think it's the latter, but there are some examples where, you know, two scientists or two engineers have two careers.
Yeah.
And it's becoming more common and easier to do nowadays, perhaps, than what it was in the past. So.
Okay, so it's which in your selection it is different fields, not the same.
That's my bias, yes.
Yeah, it's okay. We can call it
sure.
bias. It's just an opinion. That's fine. That's what we want. It's you, and you.
That's right.
Okay. So, any 40 years of teaching, research in chemistry. What has been the brightest point in the career? The best moment that you can, if you can pick one, might be many, but.
Yeah. What's maybe the most eureka moment? Maybe one recently. I was working with some other people at Argonne National Labs, which is in Chicago, where Northwestern is, and we're not too far apart. And we were having some discussions and some ideas about sustainability for a project on plastics and what to do with them, and not just recycling of it, but what's now called upcycling.
Okay.
But we needed to do the science. We needed to have a scientific basis to be able to change that field. And so we just started a project, and we did some experiments like we do, and we don't have funding for it, but we said, okay, we're just going to do the experiments. And we did this experiment. We said, look, if our ideas are right, this is the experiment we have to do. So I couldn't do them in my lab. I had worked with a lab at Argonne National Laboratory because they had the right equipment. I had the right materials for what we thought would work. We didn't know. And we carried out the experiment. And what we needed to do is take plastic, like essentially a plastic, like in a plastic bottle, which, and under very mild conditions. So we didn't want to do what the oil industry is doing, which is broadly called pyrolysis. They heat it to pretty high temperatures, make a lot of gases out of it, and then they can do something with all those molecules. We wanted to preserve the value of the plastic, the polymer, and we wanted to convert it to a liquid though.
So this was the developing new technique. This was highlight, finding out what to do, experimental, or the idea behind.
We had the idea behind it. We had to figure out how to do the first experiment.
Correct.
And we knew what we were targeting. We may get it, we may not get it, but we got a liquid, and I could later send you a picture of this liquid, the first liquid. Yes. And it was almost exactly what we wanted and actually expected, which was a eureka moment. I mean, this is how science is done. You pose a question, but it may not work.
Hypothesis.
A question, hypothesis. But sometimes it's more of a question. We can refine it to, if we think this, this, and this, then this should happen. This is the question. Because there could be various questions based on the hypothesis. But we try to get it specific. And so it worked. And it was like, break out the champagne. You know? And this was with Max Del Faro at Argonne. I should probably mention his name, because he had a huge part of this.
Okay. And what about something that you considered the lowest point, and not only in science, but in life science? Lowest point, meaning something that you regret.
Oh, regret? Wait.
Yeah.
Well,
or you would have done better.
Could have done better.
Not necessarily in science, but the idea is for a scientist.
That's more difficult, obviously.
I know. I know difficult questions. I know that.
So I could have done better.
Any regrets? Okay, 40 years.
40 years, any regrets?
Plus more, because you're in the Peace Corps. So let's say 45.
Well,
Any regret that you passed from Peace Corps to university?
Yeah.
I guess no.
No, on that one, no. It was...
Yeah.
Any regrets? Well, you know, today people use, there's a term for work-life balance, right? Mm-hmm. And I think almost everybody probably, after a long career, you think that, well, maybe I work too hard.
Yeah, that's true.
But that's pretty common, I think, right?
Yeah, now it is everywhere.
Everywhere. But if we're recording this, which we're doing, and other people are listening to it, it's important to think about the work-life balance. That's absolutely true. And there wasn't enough discussion of that when I was younger. And on the other hand, you have to realize with a work-life balance, you still have to work. So it's interesting how younger people, and in the future, how people are going to adjust to this work-life balance.
Yeah, but, correct. So it's for the young generation. So you came to my next question. What would be your advice to young generation? What is their incentive to go in chemistry, to go in science?
Oh, to go into chemistry. Well, it's a hard subject, and so it takes a certain inclination, right? But my advice would be to try to think more about the field a little broader, what you want to do, what you want to accomplish. There's various paths to do chemistry. The subject is very broad, but spend some time doing research early on.
Research early on.
Early on, and see if you like it. Sometimes you don't.
In chemistry.
In chemistry, because...
What about necessary in science in general, the exact sciences?
Well, if it's physics or material science and chemistry, they're somewhat related, you know, correct, doing research. Yes. And I think that for me, that means not just with a computer. And then you would find you would probably like it. And if you do, then you can proceed. There's lots of good universities, there's lots of good people. Find a mentor, find various mentors. You know, there is the STEM program in sciences, which is to recruit people who wouldn't naturally go into science. So that's part of the solution. Okay. Part of it. It's a good idea, it's the right idea, but it actually impacts almost everybody, because I think there is this general idea that maybe chemistry is, there's other subjects that are more interesting, or lead to this work-life balance in an easier way. But
what's your work-life balance definition?
I think you have to be, my definition is, if you're really interested in it, it isn't all that much work, but again, that's a common idea. But there are times when you have to take the time to do the work, and there's other times when then you find the other side of it in the balance. But you have to be prepared for both. It's not just get up in the morning, go to work, and come home. We all know that's not probably going to. You're probably not going to do chemistry if that's the.
So it's a balance of time, of actions, something else.
Reading, thinking, writing. All these things become important. In fact, even in this symposium that we were talking about, my students, we were at night talking, and they would joke a lot about how I would help them write a paper. They didn't particularly like it at the time, and we talked a lot about that process and joking, but to a person, they were all clear that that was one of the critical steps not just the chemistry, not just the work of doing the chemistry and the experiments, but we really do need to communicate it and publish it. And the first step of that is publishing it, right?
Correct.
And it's not easy, it's work.
Yeah, sure.
And you have to be prepared for it. But when it's done and it's finished, it's also enjoyable.
So all this life in chemistry, you found yourself 40 years working on chemistry, in solid state chemistry, in material science. So this passion is worth spending life on, about chemistry, about research.
I think so.
Because?
Because I never tire of it. I still take time to think about it.
Yeah.
I want to read about it. I want to read about what other people are doing in chemistry. And it's what you very much do in the background constantly. You know, and then it comes to the foreground. You actually do an experiment. You're working with students, and you come to a place like this. And when I mentioned I was in Samoa, and what I discovered was, in terms of plastics and this upcycling, I had an experience. We had been there a week in an Airbnb, and I had saved all the plastic water bottles. And I said to my host, I said, "Well, what do I do with these?"
That's a big issue, because that's our definition of sustainability. If you don't have a viable and sustainable technology, it's better landfill them.
That's right. And that's what she said. Put it just in the trash.
Yes.
It'll go to the landfill. So I'm actually following up with other people.
The challenge is to create a technology that can recycle in a feasible way. I mean, feasible,
That's right.
sustainable. In our sustainability framework, you have to have to protect the environment, to assure the economic growth, which is in fact is the cost of the technology.
That's right.
Economy is the factor, it's a cost of technology, but at the same time has to improve the human lives. So if you fulfill the environment, improve the human life, but the technology is not feasible economically, it will die.
That's why when
it serves not to, even in the future, those two criteria that were designed to protect the environmental protection and social development will die because of the...
Yep, exactly right. So when I came back, I went to my engineer friends at Argonne and I said, if we have this process, can we make it small enough that would meet the capacity for one small island country, Samoa? To get this liquid, we could take all the plastic bottles,
correct.
make this liquid, and put it, what it's good for, it would be very good component in synthetic motor oil.
Yeah.
And you could just capture it for that. So actually, we're pursuing that, actually.
Perfect. Yes, so you have a lot of plans in front of you. And how much time takes you to apply for grants?
You'll get the same answer from every scientist, way too much.
Too much, yeah.
It's just a fact of life nowadays.
Exactly.
And it does impact the young people because, that's one thing I think that is a real barrier, actually. And I think it will change. I hope it will change somehow.
What will change? The process of giving the granting, or simplifying the ways you apply?
A variety of things. I really think the National Science Foundation is responsive to this problem.
Yeah, correct.
I think the National Institute of Health is. They're quite different organizations. The Department of Energy is. So the first is just some awareness, right? And to provide funding based on peer review. You still have to have good review, correct. Right? And that's a competition. But the competition's all right. I mean, we all understand that. But there has to be some method to not have to spend so much time doing it.
So simplify the procedure, I guess.
Simplify things, make new rules and guidelines. But again, interdisciplinary work, which is another theme of yours, is certainly the key to making that path more defined and transparent so that it doesn't take so much time. We can't always be reinventing the same wheel, right?
Correct.
We have to collaborate.
Correct.
And
That's the purpose of SIPS and our organization is collaborating between different fields of science. And that's been very successful actually, every meeting. So a lot of plans ahead, a lot of applying for new grants. You have left behind 40 years of successful research and teaching. A lot of plans ahead, a lot of new ideas with grant application ahead. So I wish you best of luck. And as I said, we will meet you when you'll have 80 years of experience in teaching and research in SIPS.
Okay.
Correct? A pleasure and an honor speaking with you.
Yeah.
Please continue your good job and take more students in chemistry.
Thank you very much.